Good morning, students. Okay. So today we are going to discuss about periodic classification of elements. Fine. Still students they have to come. So good morning. Good morning to everyone. Okay. So can any one of you tell me what we had discussed in the last class? Anyone? Yes, we have discussed about D block elements, right? So we were talking about D block elements. Now, what do you mean by D block elements? So D block elements are nothing but Dhanyata, it should be small d. Even Gita, it should be small d. Okay, na? So D block elements are nothing but those elements where in their penultimate shell there will be filling of D subshell. Okay, there will be filling of D subshell. That's where we have the D block elements. Okay, now not in the outermost shell, it should be penultimate shell. Okay, where D block is getting filling up. So with respect to P block, Shubhangi, I think we have discussed day before yesterday. Okay, yesterday just revision with respect to P block. But especially we have discussed about the D block elements. Yes, Rakesh. Then we have discussed about how to write the general electronic configuration. So that's what we have discussed. So as Manjunath had asked, we will write some more electronic configuration. 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f, 6s, 6p, 6d, 6f, and finally 7f, 7p, 7d, 7f. So electrons first will enter into 1s, then into 2s, then 2p, then 3s, then 3p, then 4s, then 3d, 4p, 5s, then 4d, 5p, 6s, then 4f, 5d, 6p, 7s. So like that, electrons will be getting filled up from lower energy to higher energy. Okay, so electrons will getting filling up. So when I am talking about electronic configuration, another thing which we know here is that is with respect to inert gas. We should know about the inert gas, arrangement of the inert gas, right? So that's where we have helium, neon, argon, krypton, xenon, and radon. So that's where we have the helium, neon, argon, krypton, xenon, and radon. Hagadre, even we should know atomic number of these inert gases. Even we should know atomic number of these inert gases. They belongs to group 18. Inert gases, they belongs to group 18. Okay. Now, Helium, atomic number is 2. What about neon? What is the atomic number of neon? Anyone? Atomic number of neon? Helium is 2. That's what we know. What should be the atomic number of neon? Any one of you? Yes, it should be 10. What about argon? What about argon? Helium is 2. What about argon? Yes, for neon it is 10. What about argon? Atomic number for argon. Yes, all of you right. So that's where we have 18. So that is because 8 we have to add. What about krypton then? Whether we have to add 8 to the 18 for krypton, whether we have to add 8 to the 18, or what is the atomic number for krypton? Yes, it should be 36. That means we have to add 18, not 8. So that's where we have the 36. And once again, add 18 to 36. How much it will be? Add 18 to 36. How much it will be? So it will be 54. Now add 32 to 54. How much it will be? It will be 86. So that's where we have the atomic number. Yes, all of you are right. So 54 for xenon. Then we have the 86 for the radon by adding respective numbers. So who is going to decide these numbers? These numbers will be decided by number of elements present in that particular period. Got my point? As we know, in the period, in the long form of periodic table or in the modern periodic table, first period will be having 2 elements, second period will be having 8 elements, third period will be having once again 8 elements, then onwards it will be 18, then for 6th period there will be 32, and for 7th period it will be once again 32. Can you solve problems on inert gas? What problem, Manjunath? Whether you're talking about electronic configuration or what you are expecting? Because in this chapter, which type of problem you wanted to solve? Related to electronic configuration? Or we can solve it while solving CET NEET questions, if it is other than this. Anyway, which type of problem you wanted? With respect to writing the electronic configuration? Okay, that one we will discuss. So in that case, I have an element which is called as palladium. Okay, I have the element called as palladium. Okay, so some students they will get confused between lead and palladium. But lead is Pb. Lead is Pb, plumbum. So this is palladium, Pd. Pb, Pd. So that's where we have the palladium. Atomic number of palladium is 46. Can any one of you write the electronic configuration for palladium? Any one of you can write the electronic configuration for palladium? What is that, Rohan? 91. Okay, atomic number. 91 related to atomic number you are talking about. First we will go with palladium. Some exceptional one I will discuss. Okay? Any one of you have written for palladium with 46 as its atomic number? It belongs to group 10. It's a D block element, no doubt. 4D 10. Okay, Rohan. Very good. So now when I am talking about this particular palladium, since the atomic number is 46, I have to take the help of krypton. I have to take the help of krypton. Now krypton, what is the atomic number? That is 36. And it belongs to period number 4. 1, 2, 3, 4. So that means up to 4p6 we are done. When I am talking about electronic configuration for krypton, up to 4p6 we have written. Next one will be, okay, so leftover is how many electrons? 10 electrons, because 46 minus 36 is, 46 is atomic number of palladium, 36 is the atomic number of krypton, leftover is 10. Now after 4p we have 5s and 4d. In reality, it would have been 5s2, 4d, 8. All of you will agree? 5s2, 4d, 8. Now, to attain the stable electronic configuration, since this is not the electronic configuration for palladium, to attain the stable electronic configuration, palladium will go with 5s0, 4d, 10. This will be the correct answer. 5s0, 4d, 10. So what I mean to tell here is, instead of entering the 5s subshell, it's going to enter into 4d, so that it can have the completely filled electronic configuration. It is also a d block element. Now, by this electronic configuration, now we can have another general electronic configuration for d block element. That is n minus 1 d 1 to 10. Then another one is ns 0 to 2. ns 0 to 2. Got my point? So that's what we can write the general electronic configuration. So n minus 1 d 1 to 10, ns 0 to 2. Yesterday we have seen where s subshell will be having one electron with some of the elements like copper and chromium, where one electron was there. Yes, Dikshit, good morning. Okay, that's where one electrons were there with respect to chromium and copper, and we wrote n minus 1d 1 to 10 and ns 1 to 2. Now what is happening? Another example for d block element, but where s subshell is having 0 electrons. Right? S subshell is having 0 electrons. So now we can write it as n minus 1 d 1 to 10, ns 0 to 2. ns 0 to 2. All of you have understood? So that's where we have the electronic configuration, general electronic configuration. Any doubts with this? Any doubts with this? Shall we move to the next one then? So, can you write the Stephen, when it comes to higher elements, there are many factors which is going to decide. There are many factors which is going to decide which subshell is going to occupy first. See, for example, when it comes to palladium, that's where S subshell has become 0 and it has occupied to D subshell to attain the stable electronic configuration. To attain the stable electronic configuration. And 90% of the element, 90% of the element, either they will prefer to have half filled or completely filled. That's what it will be, their ground state electronic configuration. Okay, so that's where they will follow ground state electronic configuration. Yes, either they will go with half filled or completely filled. But there are some exceptional elements. There are some exceptional elements which you have to remember. Which you have to remember, because in these exceptional elements They don't follow usual trend. They don't follow usual trend. That's where those type of element, they are not much in number. Only few are there. So those type of element you have to remember. Those type of elements you have to remember. Say for example, if I take platinum, which is a costliest metal, like gold and all, even platinum is bit costlier element. Now platinum belongs to same group 10 only, like palladium. Even platinum belongs to same group like palladium. Now when it comes to platinum, atomic number is 78. Atomic number is 78. Can any one of you write the electronic configuration for platinum? Can any one of you write the electronic configuration for platinum? It belongs to same group. Yes, it is costlier metal, no doubt. Okay, and it belongs to the same group where palladium belongs to, that is group 10. Now 78 is the atomic number. Any one of you can try it out? Electronic configuration for platinum. So don't worry, when it comes to electronic configuration, only few elements which will not follow the usual trend. There are many reasons which you are going to study in your higher studies. Don't worry about all those things. Okay. Now Ullas has written 5D9 6S1. Okay, 5D9 6S1. No, it's not tough, Rohan. Among the 118 elements, these exceptional elements can be maximum 15 to 16 elements. That's all. Not more than that. Okay. But anyway, when I am talking about these elements, most of them, they are going to follow Aufbau diagram, Aufbau principle. They are going to prefer half-filled and completely filled configuration. There are some exceptional cases. Okay, I will come to that. So in that case, for 78 platinum, now we have xenon. We should take the help of the xenon, right? Now xenon is 54. Now 78 minus 54. 78 minus 54. So how much it will be? 4 and here 24, right? So 24 electrons are left over. 24 electrons are left over, and xenon belongs to 1, 2, 3, 4, 5. Fifth period. That means up to 5p6 we are done. So 5s, 4d, 5p, 6 we are done. So we have to start with 6s, 4f, 5d. So therefore I will write with lower number. So that is 4f14. Okay. So 6s2. Then what is that? 5d. Okay. 6s I will put it outside. 6s I will put it outside. We'll start with lower number 4, 5 and 6. So 5d, then 6s. Now 14 electrons among 24, 14 is consumed. That means leftover is 10. Now those 10 electrons have to distribute over here. If I go with palladium, which belongs to same group, group 10, if that is the case, I would have written this one as like this. I would have written this one as like this. But when it comes to platinum, it will go with half filled for the S subshell. It will go with the half filled with S subshell. This is not the one. Actually, electronic configuration will be 5d9 6s1. Someone had written 5d9 6s1. Someone had written, or many of you have written. Rohan and even Dikshit, all of you have written. So that's the electronic configuration. But group 10, palladium, it shows which type of electronic configuration? This type. but here it's going to change. Since it belongs to platinum, where there will be initiation of F subshell also, because it belongs to 6th period, and 6th period when it starts, there will be filling of F subshell. There will be filling of F subshell. All of you have understood? So that's where we have some of the exceptional electronic configuration like platinum. And there are many reasons. There are many reasons to explain this. Now this one tells that since there is a less difference between energy of 6s and 5d, when you are moving to the higher metals or higher elements due to increase in the atomic size, the energy level difference between outermost energy level and penultimate energy level will be very, very less. So therefore electron can easily move from one energy level to another energy level. What I mean to tell you is, see for example, I have an element, that's where I can see the energy level difference. Okay, rough diagram it is. So 1, 2, 3, 4, 5, and we will take 6th one also. This is what in a regular one we expect. But in reality what will happen? 1, 2, 3, 4, 5. Now what is happening? Now energy level difference we would have expected this much or at least this much only. But here what is happening? That energy level difference has been decreased. The energy difference has been decreased. Due to that, electron can easily move between these energy levels. That is 6th energy level and 5th energy level. So due to that, in some cases, they will have difference in the electronic configuration. Okay? So don't worry of all those things. Only thing is, these are some of the exceptional cases which you can remember. Like platinum, chromium, copper, all these elements you can remember because of that exceptional electronic configuration. Otherwise, 90% of the elements in the periodic table, they will follow usual trend with respect to their electronic configuration. All of you have understood? Any doubts? So therefore, general electronic configuration will be n-1 d 1 to 10 and ns 0 to 2 will be more appropriate. 0 to 2 more appropriate since we have elements like palladium. Okay na? Fine? All of you have understood? Okay? Shall we move to the next one? That's where we have the D block elements. So another name for D block element is, they are also called as transition elements. So why they are called as transition elements? Due to their position in the periodic table. Okay? So what is the general electronic configuration then? It can be n-1 d 1 to 10 ns 0 to 2 ns 0 to 2. But when it comes to 6th period or 7th period and all, that starts the F subshell. So for those elements we can write it as n-2 F40 n-2 F40 n-1 d 1 to 10 and ns 0 to 2. n-2 F40 n-1 d 1 to 10 ns 0 to 2. That is for lower elements which belongs to 6th period and 7th period, where F subshell will start getting filling up. All of you have understood? So that's where we have the general electronic configurations for D block elements, or which are also called as transition elements. However, when I am talking about D block elements, how many types of D block elements you expect? I will expect D block elements can be D block elements can be 3D series. Okay. So anyway, in detail you are going to study all these things in your second period. Don't worry. So 3D series, then comes the 4D series, then comes the 5D series, then comes the 6D series. Okay. So 3D series belongs to which particular period? Any one of you? 3D belongs to which particular period? Stephen, most of them they are metals. Most of them they are metals, not metalloids. Metalloids comes only in P block, not in D block. Any one of you? Yes, Chitwan, you are right. So it belongs to the period 4. What about 4D? It belongs to the period 5. What about 5D? It belongs to the period 6. What about 6D? It belongs to the period 7. Got my point? So that's where we have the D block element which belongs to period number 4, 5, 6, 7. Where they are called as 3D series, 4D series, 5D series, 6D series. So that's where you can match it. 4, 1 less 3, 5, 1 less 4, 6, 1 less 5, 7, 1 less 6. That is because n minus 1D. That is because n minus 1D. So therefore, when I am talking about 3D and 4D series, that's where I can write it as n minus 1D 1 to 10 and ns 0 to 2. When I am coming to here, I can write it as n minus 2, n minus 2 n minus 2 F14 n minus 1D 1 to 10 ns 0 to 2. Okay? All of you have understood? So that's where we have started with F subshell over here. Now if you observe, all of them they are having common as this one. All of them they are having common as this one. Fine? Any doubts in this? Anyway, don't worry about D block. In detail you are going to study in your second P. And when I am talking about electronic configuration, some elements they will not follow the usual trend, and there are many reasons. That can be electron-electron repulsions, or that can be less energy level difference between outermost energy level and penultimate energy level in case of higher elements, and there are many other explanations which can be studied in your higher classes. Fine? Shall we move to the next element, that is F block elements? So that's where we have 3D series which belongs to 4th period, 4D series which belongs to 5th period, then 5D series which belongs to 6th period, and 6D series which belongs to 7th period. That means at present we don't have an element which can be 7D series. We don't have an element with respect to 7D series. Okay? Shall we move to the next one? Next one is F block elements. Next one is F block elements. Okay? Now, in the name itself it is there. These are the elements. These are the elements which will occupy, or in these elements, in their anti-penultimate shell. Anti-penultimate shell means which is just before to the penultimate shell. Okay? So that's where we have the F block elements. So these are the elements or group of elements. These are the elements in which and penultimate shell is F subshell, and penultimate shell F subshell is filling up. filling up. Okay? Or you can simply write it as F subshell is getting filling up. That is also fine, no problem. So D block where D subshell is getting filling up, F block where F subshell is getting filling up. But don't mention as outermost shell, that's all. If you don't write penultimate and penultimate, that is fine. But don't ever write outermost shell. You can simply write it as D block elements are those where D subshell is getting filling up. F block elements are those where F subshell is getting filling up. That's fine. Okay? Yes, Rohan. When it comes to seventh period, most of the elements in seventh periods are radioactive elements. Most of them they are man-made. They are radioactive elements. That is true. Seventh period elements they are actually radioactive in nature. Okay? So especially when it comes to F block, which is also called as inner transition elements, which is also called as inner transition elements. So that is because why they are called as inner transition elements, because in this penultimate shell is getting filling up, not the penultimate, even inner to that one. So therefore they are called as inner transition element. Say for example, whether period number 3 has the F block element? No. Whether 4 are having F block element? No. Although in that energy level F subshell is available, but still when energy period number 4 comes, still we are not entering into F block. What about 5? No, still we don't have the F block. What about 6? Yes, now there will be entry of the 4F. What about 7? Yes, there will be entry of the 5F. So that's what we have only 2 series of F block elements. We have only 2 series of F block element. Okay, so one is called as lanthanoid series because they starts after the lanthanum. Lanthanoid series that starts after the lanthanum. Don't worry, in detail you are going to study about all these things. Okay, and another one is actinoid series. Another one is actinoid series. They are after lanthanum element, which is an D block element, and this is after actinium. That's where we have the actinoid series, lanthanoid series. So please remember lanthanum, actinium, they belongs to D block. Next to that one is considered as F block element. So lanthanoid series, actinoid series. Now lanthanoid series which belongs to period number 6, and actinoid series which belongs to period number 7. So which series lanthanoid should belongs to? Whether it should be 4F, 5F, 6F, which series it belongs to? Lanthanoid series. Which series which belongs to? Any one of you? Not 2 rows. Only 1 row is called as lanthanoid. Another row is called as actinoids, which are at the bottom. Okay, Tanmay, you are absolutely correct. Lanthanoid is actually 4F series and actinoid is actually 5F series, because when I am talking about F subshell, always it will follow n-2F, 1 to 14. Unlike D block where it is n-1, in F block it will be n-2. That's what we can observe there. When we are entering into energy level 6, that means period number 6, that's where 4F will come into picture. When we are entering into 7S, that is 7th period, then only 5F will come into the picture. So we don't have 6F and all. We have only 2 F block element at present, that is 4F and 5F. And that also actinoids. They are the one, almost all the elements are radioactive. Almost all the elements are radioactive in nature. Okay? So whether I am clear? Any doubts? Any doubts? Okay? So that's where inner transition elements, they are nothing but F block elements. So what do you mean by F block elements? Where F sub shell present in the ant penultimate shell is getting filling up. So now, when it comes to inner transition elements, we have two types, 4F and 5F. Why they are called as inner? Because ant penultimate shell is involved, not the penultimate one. Okay? So period number 6 is having 4F series. Period number 7 will be having 5F series. So that's where we have lanthanoid series, which starts after the lanthanum, which is a D block element. So actinoid starts after the actinium, which is also a D block element. So next to that, these elements will come. Therefore, they are called as lanthanoids and actinoids. Got my point? All of you have understood, and most of the actinoid series elements are radioactive. Don't think that actinoid series are radioactive elements. All of you have understood? Any doubts in this? Any doubts? If you have any doubts, you can ask. Okay? Otherwise, some more electronic configuration here we are going to write. We will write some of the electronic configuration for these elements also. And I will take some exceptional elements. Okay? See, for example, I have gadolinium. That is GD, which is having atomic number 64. Can you write the electronic configuration which is having atomic number 64? Can you write the electronic configuration? Please remember, when it comes to F block, we will not talk about groups. When it comes to F block, we will not talk about the groups. Okay, only period, no groups. But total 14 elements in lanthanoid series and 14 elements in actinoid series. Why 14, 1, 4? That is because F subshell can accommodate maximum how many electrons? It can accommodate maximum 14 electrons. But don't talk about the groups. No groups when it comes to F block. Fine? Because it is sandwiched between group number 3 and group number 4. It is sandwiched. So separate groups are not mentioned. Okay? So that's where when it comes to F block, only series. We have 4F series, 5F series. That's all. Okay na? So hagadre gadolinium 64. That means I should take the help of xenon. Some of you have written already. So xenon. Okay? Now, when it comes to xenon, what is the atomic number of xenon? That is 54. Xenon is 54. Okay? So naturally, leftover electron will be 10 because 64 that belongs to gadolinium, then 54 that belongs to xenon. So leftover will be 10 electrons. Okay? So we have to distribute the 10 electrons. So xenon belongs to 1, 2, 3, 4, 5, fifth period. So that means we have done up to 5p. We have done up to 5p. Next we have to go for 6s, 4f, 5d. So once again, from lower to increased number I will go. So I have 4f, 5d and 6s. Now I have to distribute the electrons. So how many electrons? 10 electrons. Now I will go with half filled for F, 4f7, half filled. Then leftover will be 3. So now that's where I will go with 5d1, 6s2. 5d1, 6s2. Otherwise, if you go with the F-bow diagram, this is the proper electronic configuration. So if you want to go with F-bow diagram, then I can mention after 5p we have 6s2, then 4f. So here only we can fill it up as 8. Okay. So here only we can fill it up if you go with F-bow diagram as it is. But here it wants to go with half filled for the 4f. Gadolinium, it wants to go for half filled for the 4f. So therefore, this is the proper electronic configuration, not this one. Okay. So therefore, general electronic configuration for F block elements will be n-2 F1 to 14, because that's where F subshell is getting filling up, 1 to 14. Then n-1 D, it can be 0. In many cases it will be 0 only, and some cases it can be 1, like gadolinium. 0 to 1, ns2. So this is the general electronic configuration. All of you have understood? Can you write the electronic configuration for cerium then? With atomic number 58, first element of lanthanide. Cerium, atomic number is 58, which is the first element of lanthanide series. Cerium, atomic number is 58. Can you try it out? What will be the electronic configuration? See here in gadolinium it has followed half filled stability. 4f7 it will do, not 4f8. So one electron it has shifted to 5d. Okay na? Now can you write it for cerium? F2, okay. So which inert gas? Naturally it should be xenon, because gadolinium and cerium belongs to same lanthanide series. So xenon. So xenon is 54. So 58 atomic number of cerium, 54 atomic number of xenon. Leftover is only 4 electrons. So leftover is only 4 electrons. So how to use these electrons, or how these electrons will be distributed? Whether 5d will come to the picture? Whether 5d will come to the picture? Very good. All of you have written proper one. So now xenon means 5p. It's done. 6s, 4f, 5d. So 4f, 5d, 6s. Now 4f will get filled up. Okay, 4f will get filled up 2. Then 6s get filled up. So 5d 0. 5d 0. So therefore, general electronic configuration for F block elements can be n-2 F1 to 14, n-1d 0 to 1, because 0 can be there, and most of the element in D subshell they will have 0. Only gadolinium and some elements can have 1 electron in D subshell. So therefore 0 to 1 ns2. Got my point? So therefore this is the general electronic configuration for lanthanide series or actinoid series for both. All of you have understood? Any doubts? So that's where we have the electronic configuration. Fine? All of you have understood? So F block elements can also be called as inner transition elements. So which are those periods where F block elements will be there? It will be 6th and 7th period. We don't have F block element in any other period. They are present only in 6th and 7th period only. Okay. So 6th period F block element will be considered as 4F series n minus 2, and 7 period elements are called as 5F because n minus 2. 7 minus 2 is 5. So therefore 5F. Okay. So that's where we have length knot series and act knot series. And once again I will repeat, no question of any groups when it comes to F block element, because they are sandwiched between group number 3 and group number 4. Okay. So no groups, only periods. It is applicable for F block elements. Okay. Now some students, they will ask the question, sir, why F block element are shown at the bottom of the periodic table separately? That is only very simple reason. That is because to maintain the integrity of the D block element. To maintain the integrity of the D block element and to maintain the shape of the periodic table. Otherwise, whatever periodic table we have, it looks like this. Right? And at the bottom, they have shown 14 plus 14 elements. That is F block. But if I include this one here, now what will happen? First of all, D block elements will get disturbed because they are uniformly present over here. But if I shift this one also here, our periodic table would have been like this. It would have been like this. That means P block, which is uniformly distributed, now what will happen? So P block will be present here and P block will be present here. Okay. Now this is where we have the D block, and in between F block will be there. So it will be making very disturbance, confusion. So to avoid these things, to maintain the uniformity, for that reason only they have put all the F block element at the bottom. Okay. All of you have understood? This is the major reason why F block element in the periodic table, they will be shown at the bottom of the periodic table. Otherwise, our periodic table would have become like this. Lots of confusion. D block, then only F block, then P block. So lots of confusion would have been created. Okay, pa. Okay. Gobar gas. Okay. Oh, in your biology you have this one, gobar gas. Okay. Okay. So, any other doubts? Okay. Yes, Dikshit, to maintain the integrity of the periodic table rather than element. Okay. So then we will move to the next one. Now this with respect to important one. Electronic configuration, they can ask for 1 mark. Okay. So general electronic configuration they can ask. Write the general electronic configuration for F block element they can ask. Or they will give the atomic number and you have to write the electronic configuration. Any atomic number they can give. So for that you should know these two information. Okay. Fine. So exceptional elements normally they will not ask. Don't worry for the board exam. Okay. Exceptional elements they will not ask. Normally, if they ask, don't blame me. Okay, na? But I don't think they will ask. That is for competitive exams. So shall we move to the next one? That is, whatever I will be talking, it will be very important. That is with respect to the atomic size. Distribution of elements in the periodic table with respect to atomic size. How the elements are distributed with respect to their atomic size. Now for that you should know one particular diagram. For that you should know one particular diagram. Okay, na? So that is with respect to atomic size. Here it is like across the period. Because period is a horizontal row, all of you know that one. Across the period, it will be like atomic size will become less. Across the period, atomic size is going to decrease. Okay, atomic size is going to decrease. Down the group, this is related to group. Down the group, vertical column, right? So down the group, atomic size is going to increase. Atomic size is going to increase. That's what you can have the rough diagram. So down the group, atomic size is going to increase. Along the period, atomic size is going to decrease. Okay? Now, for this one, down the group, why atomic size has to be increased? That's what we have discussed already. When I was talking about the period, already we have discussed why down the group atomic size has to be increased. That is because when you are moving from period number 1 to 2, then 3, then 4, here we will imagine only 4 periods I have shown. So when you are moving down the group, we are moving one period to the next period. Rohan, I will explain. You are correct, but I will explain. Okay? Now, when I am moving down the group, I am moving from one period to the next period to the next period. That means I am moving to the next energy level. I am moving to the next energy level. That's what I can give the explanation for this. Down the group, period number is increasing. Period number will increase and next energy level will be occupied or considered. Since we are moving to the next energy level, due to that atomic size is going to increase, although there is a drastic increase in the atomic number, no doubt. There is no increase in atomic number one by one. There is a drastic increase. Have you seen? Here only, from 2 to 10, 10 to 18, 18 to 36. So that is drastic increasing in the atomic number. But still, atomic size is not going to decrease. It's going to increase. Rakesh, if it is asked for 3 marks and all, you can draw at one side of your answer script this diagram, no doubt. A rough diagram. It will give overall, we have understood the concept. You can put the diagram. But don't waste the time in a neat diagram. Okay? All of you have understood? So down the group, although there is a sudden increasing in the atomic number, that means number of protons are getting increased, but still atomic size will going to increase because we are moving to the next energy level. But when you are moving across the period, atomic size is going to decrease because across the period, electrons will enter into same energy level. That's important. Same energy level. So here electrons will enter into next energy level. But here in the across the period, electrons will enter into same energy level. Okay? So same thing you can tell here. So electrons will enter into next energy level. Will increase because electrons will enter into next energy level. Okay? Next energy level. Therefore, atomic size is getting increased. But there, in the same energy level, electrons will enter. Say for example, I will consider boron, then carbon, nitrogen, oxygen, fluorine. Okay? So, period number 2. So, boron, carbon, lithium and all I have not considered. So, boron, carbon, nitrogen, oxygen, fluorine. So, that shows that fluorine is the smallest element in that particular period. If I see the atomic number, here we have the 1, 2, this is 5, 6, 7, 8 and 9. So there is a slow increasing in the atomic number, but still, although there is an increasing in the atomic number, why atomic size is getting decreased? That is because electrons are entering into same energy level. And due to increasing in the atomic number, due to increasing in the number of protons, nuclear force will act on the electrons. It will lead to contraction of orbital. It will lead to contraction of orbital. You can just mention, since electrons will enter into same energy level, so therefore atomic size is going to decrease as there is an increasing in the atomic number. That is applicable across the period. But down the group, that is not applicable because electrons are entering into next energy level. Okay? So all of you have understood? Anyway, I will stop here. If you have any doubt, let me know. This is very important. If they ask for 3 marks, you can put one rough diagram like this. Then you can define. You should give the reason. First you should tell. Across the period, what will happen? Atomic size is going to decrease. Down the group, what will happen? Atomic size is going to increase. That is one thing. Then you should give the reasons why across the period atomic size is going to decrease. That you should tell that since electrons are entering into same energy level, atomic size is going to increase as there is an increasing in the atomic number. Down the group, since electrons will be entering into next energy level, so therefore as there is an increasing in the atomic number, still atomic size is going to increase. All of you have understood? Any doubt? This is very important. That is atomic size. And if you have understood this atomic size concept, most of the properties of the elements can be explained. Okay? Anyway, in the tomorrow's class, even we have to discuss about another important one which I had left, that is related to naming the elements with atomic number greater than 100. That one we have to discuss. Then we will move to next one, other properties. Okay? Any doubts? Okay, in that case, I will stop here. Thank you. Bye. Okay, na? Thank you. Thank you, everyone. Take care. Namaskara.